Hi guys, this is Mr. Chen here, and today we'll be doing an A-level chemistry past paper series. Okay, the paper that we're gonna solve today is February March 2022. Okay, so a lot of my students actually asked me to post a solution, reason being they cannot find any mark scheme. So today we'll be going through a first paper, and most of my students are sitting for May June. Okay, so to all the May June students, May June examination students, all the best to your AS. Okay, so before we get the video started, okay, so this video is sponsored by, guess what? Woo! WeBest. And you know my famous quote, sexy, yeah, but I'm not wearing it because it's too hot, Malaysia. Okay, so what VBES is, so we are providing educational solutions to most of our students from Cambridge background, doing IGCSE, doing A-levels, and now we are actually providing education solution to Buffy student or SMAT student. Okay, so if you guys are interested to get to know us more, perhaps you can visit the link down below. So I will drop a link down below, so to find out more about us, please feel free. Okay, so without further ado, let's move on to the past year series. Okay, so I hope my battery don't die. My battery is standing at 17%. I'm not so sure it can last. Hopefully it can. Okay, so let's go. Hi guys. Okay, so let's come back. We are gonna do 2022, okay, February March series. Okay, to be frank with you guys, right, let me tell you a story. Oh my god, Indian are so smart. So by the way, this is an Indian paper. Oh my god, they are super smart. And in fact, let's say if you want to challenge yourself, you feel that A-level is super easy, okay, so please try all the February March paper. So February March, in fact, okay, I would say that it's the hardest series that you can find. Okay, so to all my major students, good luck. Okay, most of the time they will repeat some of the question in February March, so please try the February March paper. It will be super helpful, trust me. Okay, so let's go back to the first question. So first question, they are asking about first ionization energy. So to all my students, right, so I believe I have mentioned in the class, first IE, it's, I would say, high chances of coming out. So this is one of my predictions. So if you guys have the time, please go through your first ionization energy. Okay, so revisit the notes, okay, revisit all the notes given. So please memorize and understand everything about first IE. Trust me, it's super important. Okay, so first they ask you to construct an equation to represent the first ionization energy, okay, of oxygen. Okay guys, what is the definition of first ionization energy? We call it as enthalpy change when 1 mole of gaseous atom, okay, loses 1 mole of electrons to form 1 mole of gaseous ion with a charge of +1. Okay, so remember, everything must be in gaseous. Okay, so can I say that it's oxygen gas, okay, turn into oxygen plus E minus, right? Yeah. Okay, next, state and explain the general trend of first IE across period 2. Okay, it's the same as period 3. Remember that going across period, our first IE increases, or going down the group, the first IE drops. Okay, so I can say that generally, okay, so my first IE increases across the group, right? Okay, I'm just gonna use short form, yeah, guys. In the exam, please write everything because I'm lazy. Okay, so first IE increases across the group. Increases across the period. Okay, can you tell me why? Okay, first point, right, please always mention about shielding effect. The moment they ask you for IE, right, please relate to shielding effect. So you know that shielding effect is almost similar. Okay, so I can say that shielding effect is almost similar. Okay guys, I know that right across period we are getting more and more protons. So if we have more and more protons, what happens is that your nuclear charge increases. Okay, so nuclear charge increases. Okay, when nuclear charge increases, guys, what happened? Okay, you have a stronger nuclear attraction. Okay, so this is just like how many parents, how many guardians you have at home, and just imagine you yourself being electrons. The more parents, the more guardians you have, the more protons you have, the stronger the attraction, the harder for you to go out. It's the same thing, okay? So next, explain why ionization energy in figure 1.1 does not allow the general trend. Okay, so they ask you A, and why does not follow general trend? Oh my gosh. Okay, so if you look at A, so A, do you see that there's a sharp drop? Not a sharp drop, just a slight drop. Okay, from nitrogen to oxygen. Okay, if you guys not so sure about it, right, there's two exceptions that you need to know. Okay, the first exception is from group 3 and group 2. Okay, this is one of the exception. Another exception is from group 4. Sorry about group 4 pula. Okay, group 2 to group 3, another being group 5 and group 6. Okay, so you need to know the exception between group 3 and group 2 and group 5 and group 6. Okay, so if you look at it, why they ask you for A? Okay, so you know that this is nitrogen is group 5, oxygen is group 6. So if you look at your nitrogen, right, okay, so perhaps I just write down the electron configuration. Nitrogen is 2s2, sorry, 1s2, okay, 2s2 and 2p3. Okay, whereas oxygen is 1s2, 2s2 and 2p4. So 4 plus 2 is about 6. Okay, so if you fill it up right, okay, so perhaps you can say it like that. I hate this. Okay, so I just assume this is my 2p, okay, and this for nitrogen, and I'm gonna duplicate, and this is the 2p for oxygen. Okay, so for 2p of nitrogen, right, you know that all the electrons removed are unpacked, okay, and in which the first IE removed, the electron is being removed here is unpacked. But if you look at oxygen, so 1, 2, 3 and 4, the oxygen, for oxygen atom, the electrons removed from oxygen is packed. So when when there is a packed electron, they always fight. Just imagine you and your siblings in a room, so you guys always fight, and there might be there will be a repulsion. So this repulsion, right, outweighs the nuclear charge, so in which, right, the IE drops. Okay, so I can mention that, right, okay, electron removed, okay, from your A is packed. Okay, however, from nitrogen is unpacked, right? Okay, in the 2p orbital, right? Okay, next, what happened? So you know that packed electron experience a spin pack repulsion, right? Okay, apart from spin pair repulsion, what else you have? So what happened is that this spin pair repulsion outweighs the increase in nuclear charge, right? Okay, cool. So done. Okay, next part. Okay, right now, so element E is in period 3 of the periodic table. The first 8 ionization energy of E are shown in table 1.1. Okay, deduce the full electron configuration of E. Okay, so they give you a hint, which is period 3. Okay, so you know that it must be 3s2, 3p something. Okay, and guys, whenever they give you this successive ionization energy, right, okay, very simple, just look for the biggest jump. Do you see that your biggest jump is between third and fourth? So you can put a dash here. So I know that this is from the third shell, and all the electrons removed are from the second shell. Always remember, look for your biggest jump. Okay, so I know that, right, the outermost electron have 3 electrons, right? Sorry, the outermost shell has 3 electrons on it. So full electrons configuration is gonna be 1s2, 2s2, 2p6, 3s2 and 3p1. Correct? Okay, why is it so? Because that is a big jump, right? Do you see a big jump? Okay, so that's a big jump between your third and fourth IE, right? Okay, so that's a big jump between third and fourth IE. What it indicates? So indicating that, okay, the fourth electrons is removed from an inner shell, right? Okay, with a greater nuclear attraction, am I right? Okay, that's it. Okay, so no problem. Done. 3 marks, easy. Okay, so I believe for the first question, it's not too hard. Okay, if you master IE, you should be able to get all 9. Okay, so should be able to get all 9, no problem. Okay, next, let's move on to chapter 2. Okay, so for chapter 2 pula, question 2. Okay, for question 2, we are talking about period tree. Guys, again, if you are doing your recap, remember that a few chapters that you must know. Your period tree is one of them. So period tree is very popular. I believe they will repeat some of the questions in your May June series. So please go and do some recap about your period tree. At the same time, please do some recap about halogen as well. It's very, very important. Okay, right now, Na2O, Al2O3, P4O, blah, 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 blah. Okay, guys, did you define reducing agent? I know that reducing agent is an agent that undergoes an oxidation, right? Or it causes, okay, so you can mention that it causes another species or other species to undergo oxidation, right? Okay, guys, can you tell me, okay, undergo oxidation, can you define oxidation? Oxidation as in it gains electrons, so causes other species to causes other species to gain oxygen or lose electron, right? Okay, so to gain oxygen, okay, lose electron, right? Remember, other species are not itself, so itself undergo reduction, yeah. Okay, next, run an equation for Na2O with water. Okay, so Na2O with water is very simple. Na2O, okay, so I'm gonna put some state here because I'm kiasu. I always tell my student that I'm super kiasu. I'm like super kiasu Asian. Okay, let's go. Na2O plus, they say H2O, right? Okay, liquid. And eventually, it turns into an alkaline solution, which is NaOH in aqueous form. So put 2 here, boom, boom, and 1, 2, 3, 4, 1, 2, 3, 4. The equation is balanced, right? Done. Okay, next, what is meant by amphoteric? Okay, what is amphoteric is pretty straightforward. Amphoteric, it's a substance that reacts with both acid and alkaline, right? So substance that reacts with both acid and alkaline. Easy, 1 mark. Okay, next, Al2O3 is purified from bauxite. Okay, so the step involves heating Al2O3 with excess NaOH. So I know that Al2O3 is an amphoteric. Okay, so it reacts with a base, which is NaOH. So a colorless solution is formed. So guys, this equation, right, please remember it. I will put a star here. Reason being is super important. Okay, so I believe in my class, I keep saying that. Please remember this, guys. Always comes out. Okay, so please know how to construct your equation. So I know at first I have Al2O3 and I react it with an alkaline. Then don't forget to add H2O here. Eventually, what am I getting? I'm getting an NaAlOH4, yeah. Okay, so balance the equation by putting a 2, balance the equation by putting a 2, and balance the equation by putting a 3. Okay, so that would be all. Is that okay? No problem? Okay, so please write it down. If no problem, let's go. So I believe this whole section is not hard if you have done your revision well. Okay, next. Okay, we have a Boltzmann distribution constant. Boltzmann distribution graph. So for Boltzmann distribution, right, first you must know how to sketch temperature. Okay, the effect of temperature on Boltzmann distribution. Another is the effect of catalyst. So these two, right, guys, please try to know how to sketch it. Okay, so refer to my notes, or if you are not so sure, refer to the YouTube. You know. Okay, let's go. State the effect of using Al2O3, they say as catalyst. Okay, so guys, okay, I can use the graph. I can plot it on the graph. Okay, so I can say that, right, this is your EA without catalyst. Okay, you see, right, let's say if I have EA without catalyst, only this amount of particle reacts. So little, meh. But let's say if you throw a catalyst, right, I know that, okay, the presence of catalyst, what happened? Okay, it provides an alternative pathway okay, with lower activation energy, right? Correct. So you see right now, ding, 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 ding. That will be my EA with catalyst. You see that it has successfully reduced the EA much more, way more. Okay, so in which this entire section will react. Do you see that the area is about more than twice, I think? Okay, so the rate of reaction increases a lot. Okay, so I know that right now you have more particles, have energy greater than activation energy. Okay, and what happened next? I can say that your frequency of collision, frequency of effective collision increases, right? Okay, at the same time, my rate of reaction increases as well. Yeah. Okay, so how is it, guys? No problem. Okay, so next. P4O6 is a white solid have a melting point of 24 degree. Solid P4O6 reacts with water to form H3PO4. So guys, okay, this part, I'm just gonna put a star here. So what happened is that this entire section, okay, so reaction of any period 3 elements or period 3 compounds with water, so you either dissolve, they either dissolve and it shows an ionic property, or they either hydrolyze in water and it shows a covalent property. So we know that when it hydrolyzes in water, so it's a simple molecular compound. At the same time, it contains a covalent bonding, right? So I know that. Okay, so do you see that reacts with water? The keyword is reacts, guys. Okay, so when you see the word reacts or when you see the word hydrolyze, it's the same thing. Okay, so structure and bonding, very simple. So I know that the structure is a simple molecular structure. Okay, why is it so? Because do you see that they say melting point is so low? So melting point is 24. Reason being you have low melting point, right? Okay, at the same time, do you see that it hydrolyzes in water? So it shows the presence of a covalent bonding between my P and oxygen. Reason being, it hydrolyzes in water, right? Okay, guys, this entire section, please remember it. Okay, it's a very, very popular question. Let's continue with part 2. So part 2, they ask you to deduce the oxidation number of H3PO3. Okay, I know that hydrogen is +1 and I have 3 of them. Okay, phosphorus is just X because I'm not so sure about it. And oxygen is always -2 and 3 of them equals to 0. So 3 plus X minus 6 equals to 0. X equals to +3, right? Okay, so guys, it's very important for you to state the symbol here. Always put a plus or minus. If there's no plus or minus, you might lose a mark over it, okay? Okay, next, when P4O6 is heated with oxygen, it forms P4O10. The enthalpy of formation is -3012, and they ask you to calculate enthalpy change of formation of P4O6. Okay, so right now, if they ask you to calculate this enthalpy, right, my method is always construct your Hess law cycle. So you know how to construct your Hess law cycle? So this is your reaction. I'm going to put it on top. Okay, so I know that the delta R is -13272. Okay, so guys, you can draw your element box here. My element box, right, I need phosphorus. At the same time, how many oxygen I need? I need 5 oxygen gas. Okay, so link it up. Okay, forming P4O6 is how much? P4O6, it's what the question asks you to find, right? Okay, you know that forming O2 is basically 0 because you don't need any energy to form oxygen gas. Oxygen is already a gas under a room condition, right? Okay, so I can cancel this. And P4O10 is given as well, which is -3012. Okay, so can you Hess law cycle it? Woohoo! Woohoo! Clockwise equals anti-clockwise. So delta HF -1372 equals to -3012. Delta HF is equals to -3012. Oh my gosh. Did I not bring my calculator? Guys, give me a minute. I'm gonna go get my calculator. Okay, so I'm back with my calculator. Yeah, so -3012 plus 1372, -1670. Okay, 1640. Yeah. Okay, no problem. So far so good. Okay, next, run an equation between P4O10 with water. It's very simple, right? So it forms a phosphoric acid. Okay, so what's your answer? So P4O10 in solid form, okay, plus H2O in liquid form, and you form phosphoric acid H3PO4 in aqueous form. Okay, balance the equation. 4, 3, 12, 6. Done. Okay, so no problem. Okay, next. So SO2 and SO3 are found in the atmosphere. The oxidation of SO2 to SO3 is catalyzed by conversion of NO2. Okay, the first step of the catalytic oxidation is shown. So blah 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 blah, and equation to show that NO2 is regenerated. Okay guys, this catalytic converter, so this part and also your catalytic converter, please remember it. Okay, so this is one of my prediction as well. It's very, very important. So please get this part memorized like mad. Okay, so I can say that NO2 in the open air reacts with oxygen. Oh my god, NO2 is regenerated. NO reacts with an oxygen gas and you get NO2. So 2 balance the equation. Done. Okay, next, NO2 can also react with unburned hydrocarbons to form a photochemical smoke. Okay guys, by the way, this is a new syllabus, yeah. Okay, so I just want to point it out that this is a new syllabus. Okay, so if you guys are keen, I will make another video and explaining about the change in the syllabus. Okay, so then I will explain better with what are the new things that you need to know in the new syllabus, because you know that you guys are actually the first batch that sit for this new syllabus, so you guys better be prepared. Okay, so for the new syllabus, photochemical smoke. Okay guys, what is photochemical smoke? Is actually caused by PAN, a pan. Okay, what is pan, right? We call it as a peroxyl acetal nitrate. Okay, peroxyl acetal nitrate. Okay, and this is formed when NO or your NO2 reacts with unburned hydrocarbon. Okay, or we also call it as VOC, volatile organic compound. Okay, so state the product of this reaction. So I know that the answer is just pan. Okay, you can write short form for this question. Reason being pan, they accept it in short form. Okay, so or you can write peroxyl acetal nitrate. Okay, next. Figure 2.2 shows how the temperature of the atmosphere varies with height from the ground. Okay, so I know that equilibrium reaction has delta R of -168 and shows the temperature equilibrium. Where's my, okay, so let me copy this equation and I paste it here. Oh my god, my iPad is dying. I hope it will survive. Okay, so delta HR is -168. So suggest how the position of this equilibrium differs at a height of 20 km compared with the height of 50 km from the ground. Okay, so at 20 km, you can draw a line, you can pull it down. I believe the value is about negative, how much is it? 55 degree. So I know that at 20 degree, it's 55 degree. So at 20 km, it's 55 degree. What about at 50 km? Okay, if you draw it from 50 km, you draw it all the way and you pull it down. I believe it's about 0 degree. Correct. Okay, so we have the answer. So we know that from 50 km to 20 km, okay, my temperature increases, correct? No, -55. Okay, so I know that first, okay, from your 50 km to 20 km, okay, I know that they ask for differs at height of 20 km, yeah. Okay, so temperature decreases. Okay guys, you know that, right? When your temperature decreases, okay, my direction will shift to exothermic side, right? Okay, to increase the temperature back, right? Because it's reversible, increase the temperature. So where the direction will go, so I know that the forward reaction for this reaction is negative, exothermic. So I know that the direction will shift to the right, forward reaction occur. Reason being, forward reaction is, okay, so forward reaction occur. Why is it so? Because forward reaction is exothermic, right? Yeah. Okay, any question? So far so good. Okay, if no question, let's go. Okay, now guys, let's move on to next part. Okay, question 3. Hydrogen halide HCl, HBr, Hi are colorless gases at room temperature. Hydrogen halide can be formed by reacting halogens with hydrogen. Okay, they ask you for relative reactivity of halogens. Okay, so you need to tell me halogens going down. I know that going down, your reactivity decreases. Why is it so? Because increase in atomic radius. Okay, so what happens is that it's less and less able to accept electron. Okay, so the reactivity drops, right? So I know that going down, okay, my reactivity of halogen decreases, right? Okay, why is it so? Okay, reason being you have atomic radius increases. Okay, when you have greater atomic radius, the electronegativity decreases, right? So it's less and less able to accept electron. So you can mention, oh my gosh, you can mention about weaker attraction. Okay, so they are weaker reducing agent now, and because they are less able to accept electron, right? Okay, any question? So far so good? Yeah. Okay, next, HCl is a product of several different reactions. Some of these are shown in figure 3.1. Write down the equation for reaction 1. So for reaction 1, SiCl4, I know that SiCl4 is a simple molecule, liquid form, plus H2O in liquid form. Okay, so eventually it turns into SiO2, okay, a solid. And guys, when this is formed, you will see a white solid is formed. At the same time, you will see HCl is formed. Okay, and HCl is formed as a white film, yeah. Okay, so guys, the observation is very, very important. Okay, so please, okay, memorize the observation. Okay, so done. Next page, please. Okay, in reaction 2, NaCl reacts. Okay, guys, this is one of my prediction as well. Okay, so when you're doing your recap, okay, and a few chapters that you must know. First one is halogens. Okay, so please get your halogens, memorize it like mad. Please memorize it. Okay, so halogens. Okay, so the chapter halogens. Okay, so for my kids, okay, for my students, I think in my class, okay, I already mentioned a couple times about how important this part is, okay, for your halide ion acting as a reducing agent, okay, and the reaction with H2SO4. Okay, so I know that NaCl and H2SO4, they are equally strong, okay, in terms of their oxidizing ability. So what happens is that they don't oxidize each other, so they do undergo a reaction, we call it as acid-base reaction, okay. However, if you have NaBr and H2SO4, I know that H2SO4 is a stronger oxidizing agent compared to Br, and Br is a stronger reducing agent compared to H2SO4, so a redox reaction can occur. So NaBr reduce H2SO4 or H2SO4 reduce NaBr. That's it. So I know that this is a redox reaction. Okay, why is it so? Reason, you can mention that H2SO4 cannot oxidize, okay, NaCl, okay, or Cl minus, okay, but can oxidize Br minus because H2SO4 is a stronger oxidizing agent than my Br minus, right? Or you can also mention that Br minus is a stronger reducing agent than H2SO4. Okay, that's it. Okay, next, when heated with a Bunsen burner, HCl does not decompose, whereas Hi forms H2 and I2. Explain the difference of heating HCl and Hi. So I know that going down, your thermal stability decreases, right? HCl is more thermally stable. So I can say that HCl is more thermally stable. Why is it so? Okay, reason being, right, HCl, the bond is shorter. When you have a shorter, reason being Cl is smaller, I is so fat. Okay, so the bond between HCl is so short, bond between Hi is so big. Reason being I is so fat. Okay, so I know that HCl has a short bond length. When you have a short bond length, you have strong bond strength, right? That's it. So you can mention that HCl, okay, has a smaller, oh my god, sorry, Cl has a smaller, okay, ionic radius. Okay, so shorter bond length or a stronger bond strength, right? Or you can mention you have higher bond energy, right? Yeah. Okay, so this part is not hard. Okay, I believe it's doable. So once done, let's move on to part D. Okay, the hydrogen halide dissolves in water to form a strong Bronsted lauric acid. Okay, the concentration of strong acid can be determined by titration. So what is meant by strong Bronsted lauric acid? Okay, a strong means that it dissociates completely 100% to form H+. Okay, so I can mention that it's a proton donor. because of the definition, prostaglandin acid. Okay, then at the same time, strong means that dissociate completely in water to form H plus ion. Yeah. Okay, no question? If no question, let's continue. Okay, sketch the pH titration. Okay guys, this entire section is also a new syllabus. Okay, I will make another video talking about the new syllabus and things that you must know. By the way, there's no data booklet anymore in your new syllabus. Not so sure whether it is a good thing or bad thing. I would say it's a bad thing for my A2 kids and good thing for my ES kids. Okay, so for this titration curve, right, a few things that you need to know. Okay, for my student, please refer to the notes. Okay, so refer to the four-step hack. Okay, I have this four-step hack for you guys to plot it. Please follow. Okay, so for my kids here, so let's go. Okay, 0.1 mole DMQ of NaOH is added to 25 CMQ of 0.1 mole of HBr in excess. Okay, so what happened is that I know that I'm titrating. What am I titrating? I'm titrating NaOH to 25 0.1 of HBr in excess. Okay, so I know that NaOH is in your purette. Okay, so if I draw it out, so this is how it look like. So sorry guys, we are a little bit rushed here, so my drawing is gonna be super ugly, don't mind me. Okay, and I have a conical flask. This is HBr inside, right? So I'm titrating it. Okay, so the moment you measure pH, right, the initial pH is gonna be acidic. Okay, so they mentioned that, right, HBr is a strong acid, correct? Okay, you know that strong acid is always having a pH about pH, I would say 1 to 2. Okay, and NaOH is a strong base, pH is about 12 to 14. NH3 is weaker, so my pH can be 9, 10, 10 to 11. Then HBr is still 1 to 2. Okay guys, I'm just gonna put 2 as my initial pH. Okay, and my final pH, it's definitely gonna be 13. Okay, and you know that, right, if you construct the balance equation, HBr plus NaOH, okay, so you get H2O, oh my gosh, H2O plus NaBr. Do you see that ratio is 1 to 1? So I know that, right, let's say this is 0.1, they have the same mole, okay, so the volume also will be the same. So they will reach equivalence point at 25 cm cube. Okay, and this part also the same thing. Okay, now we plot the first one first. Okay, so at first, you know that when you add it into a strong acid, right, the graph doesn't vary much, so it will look like a strong, it will still look like a steady line, so you will not curve up, not really, so just a strong and steady line. Always remember, a strong acid and a strong base always gives a steady line. Okay, so you get a steady line. Okay, you can increase the pH a little bit. At 25, you get a sharp increase, or we call it a sharp drop. Okay, then until approximately 13, you can curve and you see a strong line as well, a strong and steady line as well. That's it. So this is your pH curve for a strong acid and a strong base. And guys, do you see that NH3 is a weak base? So let's say if I put NH3 plus HBr, and you will get NH4Br, right? And you see that mole ratio is also 1 to 1. So let's say this 0.1, 0.1, 25, your mole of NH3, volume of NH3 added will also be 25, right? Okay, so I know that it's also 25. Okay, at the same time, okay, my final pH is gonna be slightly lower. I will just put it around 10 point something, around here. Okay, so this is strong acid again. Strong acid doesn't vary much, maybe just a little bit. Okay, then you increase, woo! Oh my god, I don't like this graph. Okay, so approximate at this region. Okay, so it's slowly curving up. You see that it's slowly curving up. Okay, my curve is not too obvious, and I'm gonna make it more obvious. Okay, so because it's weaker base, so it will always have a curve, a small curve like that. Okay, so can see. So remember guys, whenever you have a strong acid or strong base, you will always get a straight and quite steady line. Don't tilt it too much. Okay, so you can show a line with a small gradient is fine, but not too much. Okay, but a weak acid or weak base always show a tilting graph. So you get a this graph. Okay, so let's go. So new syllabus guys, please remember, I believe May June is gonna come out again. So you must know how to plot your titration curve here. Before that, it was in A2. Now you guys are so unlucky. Okay, next we have HBr reacts with propene to form bromoalkane, CH3, CH2Br, CH2, blah 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 blah, and mechanism. Okay, so I know that mechanism here it's electrophilic addition, or I put it as E-add. Okay, guys, whenever you do all these questions, right? Okay, so there are a few checklists that you must know. So first thing, right, please show all the partial charges. Okay, I think they already mentioned, right, they say partial charges, please show it. Dipoles, please show it. Lone pair, please show it. Okay, so this will carry the first mark. Okay, next, curly arrow direction, second mark. Okay, and guys, remember, curly arrow, it's always from electron, where the electron is located, to where is the movement of electrons. Okay, and third point, okay, I would say third point, it's about a correct mechanism. And this question is 4 marks. Why is it 4 marks? Reason being, they ask you for major product. So major organic product, you must tell me, okay, which one is your major product. So according to Markovnikov principle or Markovnikov rule, so hydrogen will always go to the carbon with more hydrogen with it. Okay, so at first, I know that this double bond has a lot of electrons, so this electron dense region. Okay, so please label your delta plus, label your delta minus. So electron will get transferred to hydrogen because it's delta plus, and the bond will be broken. So electron will get transferred back into Br minus. Okay, will get donated back into Br. Okay, then what happened? So I have this H, C, H, C. Okay, guys, I'm gonna put the H here. Okay, and C, H, H. Okay, so guys, my hydrogen can either go here or go here. Due to the fact that major product, you must select a point where the carbon has more hydrogen with it. So you see that this carbon has 2 hydrogen, this carbon has just 1 hydrogen, so this wins. Okay, so hydrogen will be attached here. Okay, and this will turn into a carbocation ion, and you get a nucleophile bromide ion is formed. So again, so the lone pair will attack the carbocation ion, and eventually you get this, right? Okay, I'm too lazy. I'm just gonna copy and paste. Woohoo! How I wish I can do this in the Zan. Okay, and Br. Okay, that's it. Okay, that will be your final answer. Do you see that a 2 bromo is formed? That is your major product. If you draw 1 bromo, you will lose 1 mark. Okay, so that will be all. Okay, guys, explain why 2 bromoalkanes are not produced in an equal amount. Why is it so? Why this is major? Okay, so basically they're asking you why this is a major product. It's very simple. Okay, always remember this question, right? Always come out in the exam, yeah. Okay, so the answering technique, it's always the same. You need to tell me which carbocation ion is formed and why is it formed, because it's more stable or less stable. That's it. So I can say that because the formation of secondary carbocation ion. Okay, formation of secondary carbocation ion is more stable than the primary carbocation ion, right? Okay, it's always same, yeah. Okay, why is it so? Because you can mention that due to the presence of alkyl group with a positive inductive effect, right? Yeah. Okay, so due to the presence of alkyl group, and guys, remember that alkyl group has this positive inductive effect. Okay, so that will be all. Let's go. Okay, complete CH3, CH2, CH2Br and NaOH is different depending on whether water or ethanol is used as a solvent. Okay, guys, remember, let's say if you take H2O, right, your halogenal alkane will undergo hydrolysis and turn into an alcohol. Okay, but let's say if you use ethanol, so this halogenal alkane, right, will undergo elimination instead. Okay, so the importance of this reagent is in my note. Okay, so please go and refer it. If you forget about it, it's very important as well. Okay, so I know that when you put it into H2O, okay, I know hydrolysis will occur, or this entire reaction is just as an substitution, but you can also call it as hydrolysis. Okay, and eventually you will get an ethanol CH3, CH2, not ethanol but alcohol OH. Okay, and in organic product form you will get a NABR, right, because it's substitution reaction. okay, if you put it into ethanol, then okay, so the H and Br will get removed. I know that this Br will be gone, this hydrogen will be gone as well. Okay, so a HBr is removed. At the same time, H2O is also removed. Okay, remember elimination. Okay, we always remove H and Br. Okay, so guys, please write it down. Okay, so I know that the entire thing will turn into a CH3, CH2, and oh sorry, CH2, because there's a double bond here, right? CH2. Okay, so we get a propane instead. Okay, and guys, your Br is removed, form NaBr, your H is removed, join here, form H2O, right? So I get NaBr and H2O. Okay, any question? So far so good. So guys, this is quite important. I would say that this organic question is quite straightforward. It's not tricky. So you should be able to get most of the marks here. Okay, next, let's move on to number 4. So JK are found in plant oil. Okay, and next, complete the table 4.1 to show whether what you would observe when J reacts with reagent shown. Okay, so I know that you have a carbonyl group. Okay, so this carbonyl is basically a ketone. What else? You have a secondary, oh sorry guys, it's a tertiary alcohol, right? Okay, what else? You also have this aldehyde. So you can label every functional group present. Then from there, right, you can identify what will be the result when you add some reagent in. It will be easier that way. Okay, 2,4-DNPH, guys, this is to test for a carbonyl group, a C double bond O. Remember, it's for carbonyl, not for carboxylic acid. So for carboxylic acid, it will be a negative test. A positive, you will get a orange precipitate. Okay, what about Toland's reagent? Okay, as for Toland's reagent, it's only for aldehyde. However, we do have an aldehyde here, and Toland's reagent, a positive result, will give a silver mirror. Okay, and finally, a sodium metal. So guys, for sodium metal, it's for alcohol and also for carboxylic acid. So when you have these two groups present, okay, they will react with NaOH and effervescence is formed. Okay, so you see effervescence because hydrogen gas is formed. Okay, yeah. So J has two optical isomer. So optical isomer, I know that it must be having, you must have this chiral center. Okay, can you identify the chiral center? In fact, it's quite obviously labeled to you, right? Okay, so do you see that A, B, C, D are different things? Correct. Okay, so I know that this is your chiral center. Okay, let me draw it here, and it's connected to OH. Guys, remember, whenever you are drawing this, okay, optical isomer, right, please draw in 3D form. You need to show the bond, how is it being arranged, facing you, facing away from you. Please label every single thing. Okay, so I have OH. Then you see that on the left hand side, I have CO and CH3. Okay, so please write it as COCH3. Okay, then we have this bond facing you, which is CH3. And finally, we have a bond facing away from you, which is CHO. Okay, then please mirror it. Okay, when you mirror it, so a C and OH, and okay, this will be HOC. Okay, then after that, a CH3 is here, right? So ugly. Okay, a CH3. Okay, then this will be a COCH3. Okay, so my optical isomer is done. Remember, it's completely mirror of each other. You can see mirror, mirror, mirror. So it forms a mirror image. Let's go. Okay, next 13. Okay, reagent 1. So K is used to make the addition polymer of Perspex. A synthesis of Perspex is shown. Okay, so at first, right, we are starting off with an alkene and carboxylic acid. Can you see that? Alkene, carboxylic acid. Okay, so after that, right, your carboxylic acid turns into an ester. So I know that the first reaction is esterification. Okay, and after that, a Perspex is formed. Okay, so Perspex is an addition polymer, right? Okay, it's formed from addition polymerization. So state the condition required for reaction 1. So I know that the whole process is esterification. So I need to add this OCH3 from an alcohol, which is a methanol, right? So I need to add a methanol. Reactant L will be a methanol. And guys, remember you need to heat it under reflux with a concentrated H2SO4, right? Okay, not too hard. Okay, next, draw one repeating unit of addition polymer prospect. It's quite simple. So what you need to do, right, you just need to draw this entire thing and remember to arrange your atom up and down around your double bond. So H put up, H put down. Oh my god, it's so ugly. H up, H down, CH3 down, and COO, CH3 up. And guys, you just need to cancel the double bond, add 2 lines and put a bracket. That's it, because they say one repeating unit, right? So one line, one line, one line, and bracket. There you go. Okay, so that's it. Okay, next part. Use the information from table 4.2 suggest how infrared spectra of M and perspex will differ. So you see, right, for M, you have a double bond. But for a perspex, everything is the same except that your double bond is gone for now, right? Okay, so if there's no double bond, what happened? So I know that, right? Okay, for M, what it shows. Okay, you have a double bond, a peak around 1005 to 1680. Okay, but this peak is absent in perspex, right? That's it. Okay, so no problem. Let's go. Okay, finally, K can be made from propanol in 3-step synthesis shown. Okay, at first, I'm turning this C double bond O into a cyanide, OH and CN. So guys, I know that the type of reaction is basically a nucleophilic addition. Okay, I'm gonna put it here and add. Okay, then from a cyanide turn into a COH, I call it as acid hydrolysis. Okay, and finally, from this entire section, I turn it into an alkene. It's definitely elimination, which I've talked about it earlier. So first, I know that the first reaction is nucleophilic addition. Okay, so what do I need? I need HCN with a trace amount of KCN or NaCN, right? Let's continue. Okay, so step 1 done. Okay, step 2, right? So from C double bond, triple bond, and turn into COOH, right? We call it as acid hydrolysis. So we can just write it as acid hydrolysis. Okay, so what do I need to add is basically just acid. Any acid will do, H2SO4 or HCl. Okay, so these two acids are actually one of the best that we can use. Okay, and finally, it's elimination. So for elimination, they already gave you the reagent. So nice. Or you can also use a heated H3PO4 or silica SiO2 also can be used. Okay, so with that said, we are done. Okay, yes. So we are officially done with this February March 2022 paper. Okay, so I believe this paper it's quite challenging. It's actually okay. So in terms of inorganic, it's slightly harder. Okay, so no mark scheme are available for now. So perhaps you guys can just go through the paper and try to do it on your own. Then after that, you can just compare your answer with mine. Okay, so I believe you guys have only like few weeks left for your exam. So please do your best. Okay, all the best. Don't panic, don't stress out in the exam, and if you guys forget about anything, just think of my face. Yeah. Okay, so guys, that will be all for the session today. So I hope this video has been helpful for you guys. Okay, so please do your best and see you guys in the next video. Bye. I'm gonna make myself disappear. Bye.